So I have a new mic, so hopefully it doesn't sound like I'm entirely underwater. But this is going to be the more theoretical section of astrophysics. We're going to be doing this for a bit, and then we're going to go back to mathematics later. But really, what I want to talk about is stars, which make up large portion of our universe. So, in a technical circumstance, a star is a fixed object which is luminous, meaning that it emits light. So, anything that emits light is luminous, but it's not considered a star unless it's fixed and it tends to have quite a large mass. So, even though through this definition you could consider any sort of lamp as a star, it's not necessarily like that. Mostly because of the second point, it has to have the ability to fuse elements to retain its life. So for a star to keep on living, it will fuse elements. It will start with hydrogen to form helium, and then with helium, you can either have helium with helium, which gives you beryllium, or you can have helium with other hydrogen, getting you lithium. But during the life cycle, it actually encounters four stages, or as we call phases, that we're going to be discussing. However, we have to actually understand the magnitude of how big some of these stars actually are. So we actually use another quantity, another astrophysical quantity, and it's this thing known as a solar mass. A solar mass represents the mass of one of our suns, which we estimate is about 2 by 10 to the 30 kilograms. So currently the heaviest star, not the largest, but the heaviest we have found is R136A1. They tend to name them in sort of like just random jargon. But R136A1 has a mass of about 150 solar masses. So imagine our sun multiplied by itself 150 times. That's how heavy R136A1 is. In the next video, we'll actually be discussing what the four stages of a star's life are and sort of the ways that it can go wrong.